Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 12.3, which is going to have us looking at using proportional relationships. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to use proportions to indirectly measure heights or distances. So we're going to use proportions, which is that fraction equals a fraction, and then we cross multiply and divide to solve, to indirectly measure heights and distances. Sometimes in real life it's hard to measure, say, like the height of a tree or the height of a flagpole, whatever it may be. So we can use similar triangles to help us find heights that are impossible to measure. The other thing we can use it for is measuring distances. So if we're talking about the distance across a river or a canyon, we can use similar triangles to help us find those measurements. So this is very applicable, something you can use in everyday life if you are trying to find a measure or distance that is too hard to measure. So with that said, let's go ahead and get into our first example for today. Now, example 1 is going to ask us to use similar triangles to find the height for the following problems. So I'm going to go ahead and slide this up real quick. Now, if we take a look at example 1, for part A, we have Liam in a tree. Most situations like this are going to go with the following: that Liam is 6 feet tall and his shadow is 8 feet long. Then there is a tree that has a shadow that is 28 feet long, and then we don't know the height of the tree, and they want us to find the height of a tree. So what we're going to do is set up a proportion to figure out h, or the height of this tree. Now, if Liam is 6 feet tall and he emits a shadow that is 8 feet long, what we're going to do is set up our first part of the proportion, which is 6 over 8. 6 feet tall, 8 feet length of a shadow. So if we did height over shadow, then we need to do height over shadow on the right. So that's going to equal, we don't know the height of the tree, that's what we're trying to figure out, so that's h, over the shadow, which is 28 feet long. So height over shadow, 6 over 8, 6 over 8. Height over shadow, h over 28, h over 28. So now that we have our proportion, all we have to do here is just cross multiply and then solve from there. So if we cross multiply, we're going to do 6 times 28, and we'll pull out our handy dandy calculator. So if we do 6 times 28, we are going to end up with 168. And then that's going to equal 8 times h, which is going to give us 8h. So I now have 168 equals 8h. All we have to do here is just divide by the 8. So if we divide by 8, the 8s are going to go away on the right side. And then on the left side, we're going to end up with 21. So that means the height of the tree is 21 feet. And that is our answer for example 1, part A. So that is going to be how you do all the problems related to example 1, where they're going to give you one complete set of information for the height and a shadow of something, and then they want you to go through and figure out the height of the second object. So, to continue practice, let's take a look at B. So we have some sort of pole that we know is 1 meter tall and is creating a shadow that is 1.6 meters long. And then we have a palm tree that we don't know the height of, but it is creating a shadow that is 7.2 meters long. So, knowing that, we need to figure out the height of the palm tree, which we will call x in this case, or you could call h. What we need to do is set up a proportion and then solve like we did for part A. So if we set up our proportion, again, I'm going to do height over shadow. So the height is 1 meter, and then the shadow is 1.6. So it's going to be 1 over 1.6, and that's going to equal, if you want to call this h or x, whatever you want, the height of the palm tree over the length of the shadow, which is 7.2. So I now have 1 over 1.6 equals x over 7.2. So from here, all we need to do is just cross multiply and then divide. So if we go through and do that for this problem, so if we cross multiply, we're going to have 1 times 7.2, which is going to give us 7.2. It's 7.2 times 1. And then we have 1.6 times x, which is going to give us 1.6x. So from here, all we have to do is just divide away the part from x. So we're going to divide 1.6 to both sides. And if we divide by 1.6, we're going to end up with 4.5. So that means the height of the palm tree is 4.5 meters. And that is our answer for example 1, part B. So with that said, that's how you go through and do example 1, where you're going to go through and set up a proportion for the situation. Here we took the height over the shadow, cross multiply and divide to figure out the height of that second object that we are unable to measure or that we don't have a measurement for. Now, that is the gist of example 1. If we look at parts C and D, it's going to be a similar format. Just give us a couple more examples to reference. Part C is going to be much of the same. Okay, where we have something that we know is 72 inches tall, and then it has a shadow of 48 inches long. And then there's some flagpole that is a certain height, but that we don't know, but it is creating a shadow that is 128 inches long. So just set up your proportion where height over shadow, so it's going to be 72 over 48. And then height over shadow, so it's h over 128. So now that we have our proportion, like usual, all we have to do is cross multiply and then solve. So if we were to cross multiply here, we're going to have 72 times 128. And that is going to give us 9,216. And then our second part of the cross multiplying is going to be 48 times h, which is going to give us 48h. So then our last step to solve here is going to be to divide the number away from h, which in this case is 48. So if we divide 48 to both sides, it's going to cancel on the right. And then on the left side, we're going to end up with 192 inches for the height of the flagpole. And that's our answer. So that is our answer for part C. The last one I want to take a look at is D. Now, by this point, you should feel fairly comfortable solving these. But the one thing I want to mention with D is we're trying to figure out the height of the street light, which is h, and then it's creating a shadow that is 15.5 feet. Now, we have this woman over here who is 5 feet 2 inches tall, and she has a shadow that is 7 feet 9 inches long. Now, this one has 15.5 feet. Over here we have feet in inches. So what we need to do here is convert the 5 feet 2 inches and the 7 feet 9 inches into a decimal to match this. So that way we can go through and cross multiply. So to go through and convert this, if we take the 5 feet 2 inches, what I want you to think of 5 feet 2 inches as, we're going to start with the 5. We're going to put this in terms of feet, because this measurement right here is in terms of feet, so we want it to match the same. I know I have 5 feet, but this 2 inches. Okay, what would be the decimal? Well, if there's 12 inches in a foot, and I have 2 here, we're going to set this up as 5 and 2/12. So we're going to create a fraction. Okay, 2 inches out of 12 inches overall in a foot, because if this was 12, this would be 6, so it would be another foot. So what you're going to do is use your calculator. We're going to do 2 divided by 12, and we get this 1.6 repeating, so we're just going to round it off to 5.167. So we're going to use 5.167 as the height of the woman. And then we have 7 feet 9 inches, so we're going to do the same thing. 7 feet 9 inches. We're going to think of it as 7 and 9/12. What we're going to do here is just do 9 divided by 12, and then we would end up with 0.5. So that means we're going to have 7.75. So that means the length of her shadow is 7.75. So from here, all you have to do is just set up your proportion. So it's going to be height over shadow. So h over 15.5 is going to equal height, which is 5.167, over the shadow, which is 7.75. So from here, all you'd have to do is cross multiply and divide. I will leave that part entirely for you. Just know that your answer is going to be 10.3 repeating, which would also equate to 10 1/3. And that is how you do part D. And that is example 1 for our lesson today. So, with that said, that is how you're going to go through and use similar triangles to find the height for your different problems. And that's how you're going to find the height of objects that you can't directly measure. So, with that said, that is how we go through and indirectly measure heights. The next thing we're going to look at in example 2 is how to indirectly measure distances. And this could be distance across a river or distance across a canyon, whatever it may be. So we just have to use our situation to help us figure that out. So if we look at example 2, it wants us to use similar triangles to find the distance D for the following problems. So what we are going to do is follow the same idea that we did with example 1. The difference is that the orientation of the two triangles have changed. Instead of the heights matching up like what we saw with example 1, where they face the same way, have the same orientation, or height, height, length, length. Now they're flipped and they meet at a point. So for example 2, if we look at A, we need to find this distance d across this river. So what we need to do is set up a proportion. So we're going to use this triangle right here. We're going to use d and 24. So we're going to do d over 24. Think of this as like the distance across and then the length. So this is going to be this side length right here is going to be the side that's related to d. So if it's d over 24, it's going to be 35 over 42. So when you are setting up your proportions, okay, the two that you could think of as height or distance, okay, these two are going to match, and then the two that touch are going to be your sides that you're going to have on the bottom. So this length and this length, just like 600 and 400 for part B. So from here, all you have to do is just your usual cross multiply and then divide to solve. I think by now you should feel fairly comfortable by cross multiplying and then dividing to solve. If you were to go through and solve this one for part A, we would get a distance of 20 meters across the river. Okay, you would do d times 42 and then 24 times 35, which will give you 840, and then 840 divided by 42 gives us the 20. So same setup as you would do with part or example 1. So very similar. It's just the fact that the orientation of the triangles has changed. So just be careful when setting up your proportions. So if we were to practice setting up proportion for part B, so we need to figure out the distance across this river right here. For this triangle, we have 327 and then 600. Think of this as the distance and then this as the length. So we're going to have 327 over 600. This is the distance and this is the length. So the distance goes on top and then the length is going to go on the bottom. So we're going to have 327 over 600 equals d over 400. Think of these two parts as your distance and these two parts as your lengths. And that's going to really help you set up all of your proportions for today. So keep that in mind. All right. So all you have to do from here is just cross multiply and solve. So you do 327 times 400, which would give us 130,800. And then you would divide by 600, and the distance across the river in this case would be 218 feet. Again, all you're doing here is the cross multiplying. You would do the same thing for both parts. I'm just not writing it all out just to kind of save us time from typing it into the calculator and then to multiply and then to divide and just kind of giving you your answer. If you'd like to practice that cross multiplying, making sure that you can calculate it correctly to get 20 meters and then 218, by all means, go ahead and do that and get that practice. So with that said, that is how you go through and do example 2 for using similar triangles to find the distance d for different situations. Now, part C and D are just going to be the same setup where you're going to have the distance over the length, the distance over the length. So for C, when you would go through and set this up for part C, we would have d over 12 and then 12 over 6. Now, I'm only going through and setting these up just to give you more of a reference and more problems to kind of match it with. So we have d over 12 and then 12 over 6, distance over length, distance over length. If you went through and cross multiply to solve this, you should end up with D equaling 24 meters. So the distance across, let's say, a canyon in this case, would be 24 meters. Now, last one, just to kind of quickly run through. Again, we want to go through and set up our proportion. So we have distance over length. So D over 48 is going to equal distance over length, 80 over 60. Distance over length. So now all we would have to do is cross multiply. And when you cross multiply, we would end up with the distance being 64 meters. And that would give us our answer for part D. So again, if you want to go through and practice actually calculating these to figure out and make sure you're on the right track, you would just cross multiply. So D times 6, and then 12 times 12, and then you would just have to divide. And then D times 60, and then 48 times 80, calculate, and then you would have to divide the 60 to the other side. So, with that said, that is it for section 12.3 on using proportional relationships. I hope the video was helpful, and I hope you have a good understanding of what to do today. Your homework, be sure to reference the completed notes or come back to the video if you need a refresher. If you have any questions, as always, feel free to shoot me an email or just let me know the next time you see me. And that is it for today. So thank you guys for listening. I hope you have a great day, and I will talk to you guys later. All right, bye.